Hey guys, Mr. T here. This is your last sort of idea or topic in trigonometry. Another real-world application of it. So the idea is true bearings. So angles in trigonometry can also be applied when you describe directions. So if you're doing orienteering or if you've done scouting or anything like that, you may have experienced this. But let's see how maths applies to that. So directions can be described by comparing them to true north. Direction and true north will be, in this idea of true bearings, 0 degrees. If you're traveling at 0 degrees, you're going directly north, directly up on a map. So directions compared to true north are known as true bearings because they're compared to true north. So let's consider that you were standing at a point A facing north. So let's say you were standing here at A and you're facing up north. And you turned clockwise through an angle, theta here in this case, until you faced B. The bearing of B from A, so B from A, this angle here that you've turned, is the angle that you've turned, and that is the bearing. That's the true bearing of B from A is going to be whatever the angle is there that you've had to turn from facing directly north, 0 degrees, to wherever you turned to be facing B. So first thing to think about here is true bearings are always written with 3 digits, e.g. if you turn 72 degrees in this case, you would write it as 072 degrees, not just 72. And also the other thing to think about is the bearing of B from A, let's say here was 72, and A from B, are always going to be different by 180 degrees. So if we were to say this was 72 degrees, for example, that 72 is B from A. What's the bearing going to be A from B? Well, you're going to have to turn clockwise, facing north from B, and they're going to be always 180 different. So it's going to be more. It's going to be 180 more. Why is that? Because if we straighten this line here, this angle 72 degrees would be that portion of it, 72 degrees, and this turn around here is 180 degrees. So it's very simple to work out the true bearing if you're going from one point to the other or vice versa. You just add or take 180 degrees. So 180 plus 72. So this whole angle here, this whole turn, this true bearing is going to be 252 degrees. So A from B is 252 degrees, true bearing, and B from A is going to be 72 degrees, true bearing. Okay, so that's an example of some things to note. So let's try some actual maths, some of the exercises that you might have to do. Draw a diagram to represent 045 degrees bearing from 0, the origin. So let's say 0 is the origin. North is 0 degrees. So 45 degrees is going to be exactly between 90 degrees, which is east, halfway between that and 0 degrees north. So that is 045 degrees bearing there. That's a diagram of that. Next, find the bearing of Q from P in the diagram below. Q from P. So Q from P, the bearing is actually going to be this angle here, because from P you're facing north, and you would have to turn clockwise all the way to where Q is. So let's have a think. This angle here is going to be 180 degrees, and the remainder is going to be 55, so 180 degrees plus 55 degrees. Ooh. Graphics calculator. 180 plus 55, 235 degrees. So you'd write it Q from P to 35 degrees. True bearing. Alright, let's do a more mathematical problem solving question here. Starting from A bike travels east 7 kilometers to B, then travels south 3 kilometers to C. Find the bearing of C from A. So we need to draw a diagram here. A bike travels 7 kilometers to B. So 7 k's to B. Then travels south 3 kilometers to C. That's not to scale, obviously. Actually, I'll draw that better. It needs to be like just a bit less than half. C, 3 kilometers. Find the bearing of C from A. So it's really asking what that angle there is. But to find that, we're going to need to work out, because that's not this shape here. This is not a right angle triangle. We have a right angle triangle here. So we can work out, we need to work out what this theta is, because that's in the right angle triangle, before we can work out what the overall bearing is. So let's do some working out here. Let's use some trig. We know we're going to need to find that angle there. So this is the adjacent. This is the opposite. We don't know the hypotenuse, and it doesn't matter. We don't care about the distance from A to C. We're worried about the angle. So saw, ka, toa. Which of these ratios involves the opposite and the adjacent? Not this, not this. So it's going to have to be tangent. So tan of the black theta, which we don't know yet, is going to be opposite over adjacent, 3 over 7. Now we want to work out what the angle is. We need to use the inverse tangent. So it's going to be tan negative 1, 3 on 7. So go onto the calculator, make sure you're in degrees mode. So inverse tan 3 over 7. On your iPad calculator, you should do 3 over 7 first, and then do inverse tan. So theta is actually going to be the black one, 1986 degrees to 4 decimal places. So we know that this black theta here, 23.1986 degrees. Now we need to work out what the red theta is, that whole angle. Well, we know this top portion is 90 degrees. Therefore, the whole angle, the true bearing, is going to be 90 plus 23.1986 degrees. It's going to be 113.1986 degrees to 4 decimal points. Therefore, C from A is 113.1986 degrees true bearing. Because that is how far you would have to turn from A, facing directly north, in a clockwise direction to face C, where you ended up. Okay? So hopefully that helps you out with true bearings and some problem solving you'll need to do. And I'll see you in whatever the next video is.